Hi, this is Catherine Skinner of the Educopia Institute. This workshop recording and all of its accompanying material is openly and freely available as part of a research project undertaken by the Educopia Institute in partnership with Carnegie Mellon University, Colorado State University, Indiana State University, the Morehouse School of Medicine, Oregon State University, Penn State University, Purdue University, University of Louisville, the University of North Texas, University of Tennessee at Knoxville, and Virginia Tech University. It has been generously funded by the Institute of Museum and Library Services. This workshop has been designed to provide you with resources and tools that will help you to know how to handle version control. This workshop is part of a 6-workshop series on topics related to the preservation and curation of research data and complex digital objects. You can access these workshops and all of their accompanying materials, including guidance briefs and handouts and slides, at https://educopia.org/research/ETD+. Now, where and how you manage different versions of your research materials and writings is going to help determine your ability to get back to the right version, the one that you're seeking in the future. So in the pre-digital environment, version control was different. Students produced a thesis or dissertation that was a written document. It was text-based. They typed it up. The institution reviewed it and then shelved it and/or put it on microfiche for posterity. Now, instead of managing those physical documents, you will be managing and turning in a set of files. So this workshop will provide you with an overview of the challenges and opportunities that digital version control poses and provides for you as a researcher, particularly regarding your ETD-oriented research outputs. So some of the things that we'll be looking at is, how do you make sure that you know which file is your final file? How do you make sure that your research output's history is something that you can revisit as necessary? How can version control help you or someone else to use and build upon your research outputs in the future? So with all of that in mind, let's look at the learning objectives for this particular unit. So we want to help you understand that your research files are going to change over time. And with that in mind, we want you to learn how to use naming and storage conventions to version your research files, making it easier to know your research history. And then finally, we want you to gain familiarity with software tools that can help you with versioning, particularly when you're collaborating on documents with others. So let's talk about version control and why it happens in the first place. So research is an active and iterative process. You're going to edit and re-edit your research materials many, many times before you finish your thesis or dissertation. So how will you know that you are working with the most current revision of your materials? You can accomplish this through a process called version control. And version control, which is also known as revision control or source control, is the process of managing changes to your files over time. So version control can help you to track your revision history, including the when, the why, and the by whom changes are made. It can also help you to revert to earlier versions of a file when that becomes necessary. And there are lots of scenarios where versions come in handy. You may need to take your analysis in a new direction halfway through your project. You may need to go back and fix a mistake. You may need to review your research steps. You may also need to double check something, or you might need to make a new version from an original. So for example, if you created a smaller version of an image for one purpose, you may need to return to the master or the original version of that image if you want to create another different sized version. In order to successfully return to an earlier version, a copy of that version needs to be stored somewhere that can be identified and accessed later. So ultimately, version control is all about process. The process might be manual, it might be software assisted, but it requires organizing the way you work. And the image here provides an example. It's far from perfect, but it does show a real world example of version control in action. So what are we looking at here? The key is that there's a process that stays consistent and that yields file names that can stand alone and still make sense. So here you see 2 layers of version control in action. You're looking at a set of embedded folders. And where it gets interesting is at the last folder stage. So note that those are dated and the revisions are marked. So 2016 03-23 revisions is presumably a folder full of revisions of guidance documents that were produced on March 23 of 2016. So now why is this dated 2016-03-23 instead of 03-21-2000 or 23-2016? So in other words, why is the year first rather than the month first? So even though month first is the most common date convention in our day-to-day life in the US context, the year first works best because the year is going to be your most stable figure. And what you want is for your string of files to rank naturally by year first so that all of your 2018s are together, all of the 2001s are together, etc. So think about how this would look if instead we use the month, day, year format for the numerical string. The revision folders would stack very differently. And once you get into multi-year projects, the years would scramble because they come last in the numerical string. So for example, if instead of having the year first, you had the year last, you could have January 25th of 2017. So 01-25-2017. And then under that, you might have March 23rd of 2018. So 03-23-2018. And then under that, you might have May 23rd, 2015. So 5/23/2015. So all of a sudden you've got 2017, 2018, and 2015 in a row, which just doesn't do anything in a human readable way that allows you to quickly navigate and understand what it is that you've got. So a simple method for designating revisions is to note it at the end of the file name. And this way files can be grouped by their name and then sorted by their version number. So for example, look at this first list, which we've labeled OK here. So image1 underscore v1.jpg or image2 or underscore v2.jpg. So by looking at this, you can pretty quickly discern that you're looking at the first image and the first version of that image, and the second image and the second version of that image, etc. Now, if you use version numbers in this way, one of the issues that can arise is that computers are going to sort files based on the position of the characters. So this can lead to strange and sometimes unhelpful results. For example, the oops column that you see here. So if you've got a version 10 and you've started with V1 as version 1 instead of V01 as version 1, then you're going to have a problem. You're going to have the ranking not fall in a way that is human sensible. It's going to be machine sensible. Likewise, if you wind up with 100 versions of a file, which is possible, then if you haven't started with V001 and you have V01 and then V100, you're again going to be falling into these problems where it doesn't really rank consistently. So a good practice that can help you to avoid those problems is to use dates to designate your version numbers. And if you choose this strategy, you can format your dates as year, month, day, as we discussed on the previous slide. So using this order is going to help you avoid confusion when you're collaborating with other researchers or with systems that use a day, month, year, or month, day, year kind of format. And it's going to help your computer to automatically sort versions in chronological order. So if the files that you are using are created or edited collaboratively, you may also want to incorporate names or initials into your file naming conventions so that you know which versions contain updates by each individual on your team. So for example, here we've got dataset 1, and then we've got the date string, and then we've got initials for KES, WTC, GSC for 3 researchers that are participating in a particular project. So more powerful methods of version control include the use of software tools like Git, GIT, and Subversion. These tools store your content in such a way that they can actually remember its state from revision to revision. And usually these tools allow you to check your content in and out, which ensures that revisions never happen simultaneously in 2 different locations. So for example, if 2 researchers are working together on a project and both attempt to revise the same file at the same time, this kind of check in and check out process keeps them from accidentally doing so. Now, some of the key differences between these software-assisted methods and the manual methods that we described previously include that first, you can only view and edit the working version of a file in these version control software environments. And then second, when you change a file, you can save a revision and attach a short summary of your changes, which is way cool for, having this human readable, very quick summary of what it is that you did to change the content in that revision. So while version control software was developed by coders for coders, so it was really developed for coding environments, software environments, it can be used to manage any kind of data. But using these tools does require an investment of time to learn how to use them properly. There are extensive guides and tutorials and classes for these version control tools, and they're available for free online. A few resources that you may find helpful are listed on this slide, including some file naming advice from Matrix Research Center at Michigan State University, a free online class about Git and GitHub from Udacity. There's another helpful GitHub guide at Hello World. And then finally, there's a free book that was authored by Subversion software developers that's called Version Control with Subversion. So these will give you some entry points into some deeper information than what we can provide in a short workshop like this. You'll also find additional resources if you turn back to the URL that we provided at the beginning of the session. And you'll find this in that same folder that I mentioned previously, and that is at the bottom of the screen as well. So that is at https://educopia.org /research/ETD+. And this particular slide is a handout that you'll also find on that at the URL. So this is something that you can take with you, you can print, it's simple to refer back to, and it summarizes a lot of what we've been through today. So 3 main issues that you should be familiar with at this point are, first and foremost, that your research files are going to change over time, and that as a result of that, you need to ensure that you will know what each of those files is, and that you establish a clear historical record of your research creation process. So instead of saving over a file over and over again, save versions of the file as you make changes to it. Second thing that I hope you've learned is that an easy way to do this is just to establish a standard way of naming and storing your files that makes it easy to tell what is what. And then finally, you may also rely on software tools that are made to version your content. So things like Subversion and Git. And these are especially useful when multiple authors and researchers have access to the same file or may make changes to a file over time. So that's all I have for you on this topic. Please visit the URL, as we mentioned, for other resources, and best of luck to you.